Hey, what's up guys? Welcome to a new video. Today we will be trying to solve this AIO problem called tag. It's a fairly simple problem, but what I actually wanted to do with this problem was go through two methods of solving it and how time complexity and the time to run the algorithm really affects the way we solve and the time it takes to solve this problem. So let's just have a look at the problem statement first. Basically, you have n people playing and each person has a different number from 1 to n. At the start of the game, player 1 is on red team and player 2 is on the blue team. Everyone else starts on no team. So over the course of the game, people will join the team, people who are tagged will join a team, and then the person who has been tagged joins the team of the person who tagged them. So using this logic, we can just devise a super simple algorithm. What our algorithm will do is we'll have someone on the red team. Oh, let me just do some paint. We'll have someone on the red team, and then we have someone on the blue team, and then we have just a set of n minus 2 players. And now every time the red will, let's say after the first round, first tag, now there are 2 red players, there is 1 blue player, and minus 3 players. And the second person, alright, let's also give them numbers. Let's say this is 1 and this is 2, this is 1 and then this is person 7, this is person 2. And let's say that first tag, person 1 tags person 7. Now person 7 becomes a member of the red team. Let's take a second scenario. So the second tag. Let's say now 2 people have joined the blue team. Players. So we have players 1 and 7 on the red team, but now we have 2 and let's say 4, and n minus 4 players remaining. And in the second tag, thus player 2 has tagged player 4. So essentially player 4 has now become a member of the blue team. And now membership testing will come in handy later. So using that basic logic, what can we do to solve it? Well, we can create a list first of red team members and blue team members. And let's say we take the input from a file, the player count, which means the amount of players there are, and the tag count, which means the amount of tags that has happened during the game. If we go back to our input from the file, you can see the first 2 lines give you the number of players, the number of tags happen, and for the next, tagged lines, we have all the tags. So player 2 tags player 7, player 1 tags player 8, player 8 tags player 4, and so on. So what we basically do is every time player 1 or player 2 tags someone, that someone becomes a member of their team. So now whenever that person tags someone, we know that that has come from either the blue or red team respectively. So let's see how this works. So we go through all of the tags, we find the 2 players in the who are in the tag scenario. The A, or the first person, is always going to be the tagger, which means they're always going to belong to a team. So if the A person is in red team, then we add them to the red, we add this next, the B person to the red team because they've been tagged. Same thing for blue. If the tagger was in the blue team, then we'll append the person who was tagged into the blue team, and so on until we have 2 full teams at the end of the game, or at the end of all of the tags, because some people can end up without a team. Then we just have 2 answers. One from one, well, it asks us to have two answers: the number of players on the red team at the end of the match and the blue team at the end of the match. So we've got the red team. We take the length of the red team people and the length of the blue team. So this looks perfectly fine. So if we copy this code and paste it into the submission, let's see what happens. Oh, you can already see we're developing an error, time limit error. Our solution is correct, but we're running out of time. We're going over time. And why is this, you may ask? You may think that on the surface we're only iterating it for the amount of tag counts, so it might just be O of n. But no, it's actually O of m times n, and here's why. So we've got O of m, let's denote m as tag count. So we're going through it m times at least, but within the m time, we have this if statement here. If A in red team, remember red team is a list, and if we're trying to find an element in a list, searching a list is also O of n. Thus our time complexity will be O of m times O of n. Now, how and why does this happen? So basically, when you have a list of n elements, to find an element in a list, what you have to do is search through every single element until you find the desired element. Thus, its worst case complexity is O of n. So, how can we fix this? Well, we can just use a different abstract data structure, a different structure called a set. So, what sets allow us to do is it allows us to search for an element using the same method where we search for a method in the search for a member of the team, except the membership test, or the searching, is constant, O of 1. That is because when we assign a member to our set of n elements, we actually do a process called hashing, or we implement it through a hash table, where our element 1, which is our key, our element 1 is hashed to a space in memory. Thus, taking it out only requires one operation. And that is also why when you add new values to a set, it becomes unordered. So let's look at this big O notation graph. You can see that O of n, which is our algorithm that uses this linear searching time, linear time, runs much faster than, let's say, O of n times m times n, which, let's say m was the same length as n, that'd be n squared. But we don't know, it's generally much worse than O of n. So, as you can see, the reason it's O of n, because we only search through it tag count times. Then all our operations are O of 1 here, so they don't get counted. Now let's see what happens when we run this into our judge. As you can see, it runs much faster and we complete all of the subtasks. So that's basically a wrap on what happens when, on the difference between searching times and the niche little aspects of algorithms to make your code faster. So you can see that the O of n runs much faster than the O of m times n. That is because list searching is much slower than set searching, because the membership test for a list is O of n, while the membership test of a set or a dictionary is O of 1. And that is one way you can improve your code when writing faster, by writing faster algorithms which implement lower searching time data structures. Thanks for listening. I hope I explained it pretty well, and I'll see you in the next video.